Hello, welcome back. And tonight I will be doing a stream on me optimizing some existing code I have. And this existing code is the LOGICSIM code. If you've seen my YouTube shorts as of late, you can see that I've been working on the Altair 8800 and I've been trying to create a logic gate simulator to draw code and stuff, to draw logic gates and simulate them on the Altair 8800 simulator. And now this simulator, which uses an Arduino Do, is a very special terminal called the GEF terminal. GEF, this thing right here. And basically it will allow you to draw lines, rectangles, circles, all sorts of things on the native VGA display. I think it's like 432 by 288 pixels or something like that. It's 80 columns wide. Yeah, it's a 24. It's the 80 by 24 column display. And yeah, this is a graphical program, and I have it written here. Now, very good friend of mine, old coworker, has helped me out a bit. He's given me a bunch of pointers on how to optimize this code to make it even smaller, make the binary even smaller, because right now the binary is 170 records total with libraries, and that 128 bytes per record. That's about 200. That's 22k, 22 kilobytes of RAM taken up, especially for a computer that has 65 kilobytes of RAM and only about 48 kilobytes of working memory. That's kind of a lot. So I'm trying to pare that down, as well as maybe make it a little faster. There's other tricks I can do to make it faster, but that's kind of outside the scope of this stream. And if I can make it smaller, I can fit more things in it for the same, fit more features in it for the same amount of space. So yeah. And what is this? I have no idea. Basically, let's look through. So the past few days, I have done some lookup tables like this. Very proud of this. I have completely redone the device drawing code. So it's a lot different than it was before. Basically, it's a lot easier to use now. Unfortunately, the size savings wasn't that great. All the code that I use to draw, where is it? Oh my god, I need bookmarks on this thing. All the code here that I used to draw sort of offset the code that I saved in the shapes. So, oh well, things like that happen. So anyway, the next thing, Eben, my old coworker, he's a fantastic programmer. I hope to one day measure up to half of his ability. Truly. He may not be the best programmer in the world, but to me he is. He worked at DEC, which did the P2P computers and stuff. He got to grow up, and he had the privilege to grow up and work for companies like DEC that ultimately created what we have today. Without DEC, we wouldn't have Microsoft XP, really. Take a look, VAX, the VAX operating system is DNA, if not some of the code, don't quote me on this, some of the C code at least, not the assembly obviously, that is put into Microsoft XP when Microsoft was experimenting around. Anyway, what he said, and I can't believe I didn't think of this sooner at all, was that the connections, which are the air wires, the connections don't need source, target, and source. They don't need source and target XYs. Like, obviously, when you draw the wires, it is simply just an offset. If not, just grabbing, the device's X position plus the shape to the output, to the output vertex. That's the offset. That's all I need. I cannot believe I did not see this, and this would actually save me a ton of code, because a good chunk of the problem of this code here is actually updating. Like this code right here is updating the coordinates, and they really don't need to, because they don't need to have coordinates. So I can't believe it. Now, the interesting thing about LOGICSIM is that it's actually very fast, considering what it is. The slowest part is actually the screen. If the screen was, very snappy, I wouldn't even really care about the speed of everything else, because it's just that fast. Even if this is a 2 megahertz 8-bit processor running C code, it's just fast enough, and my code just isn't that bad enough to cause problems for that sort of speed. But we're gonna cut it, because I don't need the space, I don't need the speed, and I don't need the speed decrease, and let's just cut it out. So what I'm gonna do is, at first I was like, I'm just gonna cut out the XY stuff to begin with, because I don't need that. No, I'm not gonna do that. What I'm going to do is I'm gonna leave that in there right now, and I'm going to redo the drawing code for these connections, the air wires. Now, remember, connection is just a straight air wire, nothing else. So I can just draw a line. And I regret to inform you, I do not have a USB cable extender, so I can't have a live feed to the Altair monitor to show you the stuff working. But so I'm just gonna have to relay to you what it looks like, and hopefully very soon I will get the extender so I can have my an extra webcam set up, so you guys can follow along with what's going on. I could do like a VGA capture card, but I do need a VGA capture card at some point. Anyway, let's do this. So let's just do this. Devices. So let's do. Ooh, this is. Ooh, shit. Hang on. So this is what I want to do. I want to do x1, y1, x2, y2. Okay. Let's see. So if I were to draw, hang on, I'm trying to go walk in. If I draw, I don't think I need the connection struct at all, except for this. If I draw device, if I draw connection, it's K dot, and then if I look up, source device and target device, source dev, this will give me the device, this will give me the device. Source dev dot x will give me the connections source dev pointer to the device I want to draw x location, plus, and then here's the fun part, I'm going to do devices, I'm going to do the same thing, I might pre-compute these because, you know, speed, right? Hello, whoever you may be, please enjoy. I'm just writing code, and if you don't know what I'm writing code for, it is check my most latest YouTube shorts. It is C code for a logic gate, a graphical logic gate simulator written for the Altair 8800, a 50-year-old processor on a 40-year-old computer in C. And I'm trying to make this as small as possible. So yeah. Okay. Dot shape, and then we can count. Oh boy. Okay. So we gotta check the device type to see if it is a signal or something else. So if it's a signal, we're going to have to assume the last two of the shape is the vertex I want to draw from, right? If not, it's got to be this one right here. Okay, so that's 1, 2. So let's do that's 1, 2, 3, 4. Sorry, 1, 0. Ooh. Oh my god, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So those are the indices I need to draw from. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So let's go all the way down here to the drawing code. So 14 is X, 15 is Y. I'll do a note for myself here. Check if signal, if so, use 1, 2, 3, 4, 5, and 6 as in 6. Cool. Okay. So basically, I'm drawing the offset. And now let's do this. So this is 15. Okay. So we drew from the output of the first device. Now we have to draw on the input of the second device. And remember, inputs, I have 2 inputs. So how do we account for that? How do we account for that? Indeed. Okay, let's use your brains here. So first we do want to okay, we want to draw the target X and Y. Okay. Plus what do we want to do? I want to grab the target device's input. So let's do that. Devices, connections, okay, dot targ dev dot, and then this should just be input in dev. Okay. Okay. So I think what I'm going to do is I'm going to just pre-compute these first, because this is just kind of a nightmare. And I'm sure I can go back in and do some optimization still. So let's do that. Let's take these. Okay. Say int x1 equals int y1 equals. Okay. Unsigned char dev pointer equals dev s pointer. Okay. So we don't have to just pre-compute, so we don't have to compute everything on the fly. Okay. Target pointer. Cool. Okay, so then what I'm going to do, x1, y1. Okay, now if devices dev t pointer dot hang on. Okay. I'm just trying to re-realize what's going on. Let's think about this again. What's happening in indev is I have two pointers. I need to sort of designate, like, let's do this. I'm going to change in dev to an int. The reason being is because what I'm going to do is I want a 0 device, but I'm going to designate a -1 as unconnected. So disconnect will now be the mode I gotta check. So now if I go down here, and I can say that, and then what I do I think I'm just thinking, I think that's all I have to do is just switch them to disconnect, because the way what happens is if I have a connection and I delete it, then the next connection up in the list will get shifted back down. So any connections that may or may not have will be moved down. Oh man, I can just foresee just problems happening if I don't get this right. I can just foresee problems happening. Oh, this is a nightmare. Okay. I feel like the longer I think about this, the more problems I'm like running into unnecessarily. You know what? Let us take this. Okay. Take this. And I'm going to just comment this out. And then I'm just going to we're just going to do this. And then I'm going to build it. Of course I have 2 errors. Why would I possibly not have 2 errors? Ugh, dry line. There we go. Howdy. How you doing? Okay, built. Now, let me transfer it over to my Altair. sending the file. Yo man, what's up? How you doing? Just writing code, and as you can see right here, I am sending it to my computer. I know I don't have another, I'm gonna get like another webcam and an extension cord so I can, like a USB extension so I can show you guys, but yeah, I'm just sending it over. There, it's done. Well, let's launch it. Okay, so I'm gonna look over to the left and I see that I'm drawing a device. Now I'm gonna go over. Too many numbers, dude. It is quite a bit. It's when you're dealing with code this small, that's kind of just what you got to think of. It's unfortunate if you're working on like modern systems with an actual computer, not a 40-year-old computer, then you can think in English instead of numbers, but you don't have the luxury of that with this. So I'm going to head over here and I'm going to tell you if it works or not. I'm making a device. I'm changing it to a NAND gate. I'm going to switch to connection mode. I'm going to insert. I'm going to do 0 to 1 and I'm going to connect to 1. So you guys can't see it, but it draws. Oh no, it draws. It draws great. It doesn't draw right, but that's because basically what's happening is I have the input line here. I have like the signal, and the wire is starting to draw down here. But that's because I don't have a check, because I have it right here. I have a check right here. Check to see if signal, and if not, do that. So I need to do that. So if devices source pointer dev source pointer dot type equals, thanks man, if it equals signal, then basically I'm going to do this code, else I'm going to have it do this code. Cool. And then else draw from device output line. Cool. So it should be pretty easy. So basically, let me just do this. And then oh my gosh. Do we really need to? Oh my god, I guess you're right. Here, let me take this and then move it down here. Here we go. Basically, optimization be damned. Optimization be completely damned. Basically, bro, I have to compute the coordinates for each device. If it is a signal, I have to compute the coordinates differently than if it is a device. So that's why I'm just gonna have to do it like the same thing. And I said this is going to be 5, and this is going to be 6. Cool. And actually, I can just do this. Boom! Look at that! Isn't that cool? Because I'm drawing it on both if statements, I can just draw it once afterward instead of drawing it twice on both. This will probably be, yeah, there. This will probably be computed the same. right, and what I want to do is I want to do this. I want to do int x1, y1, y2, x2, y2. I don't know if you remember Lightfire, you know, plot lines essentially. That's essentially what I'm doing. Well, thank you. And then, of course, because I'm declaring ints up there, I'm going to just remove the declarations because, you know, compilers and all that, right? Actually, it's called stack. Too bad. I don't care. I do care. That's why I'm fixing it. Anyway, cool. Now let's try that. So if I go here, submit, let's see, let's build it. Cool. No errors. Now let me go close the program out over here. Okay. I close the program. Now erase LOGICSIM.com, pcget LOGICSIM.com, and then let me just send it over. LOGICSIM.com. Twiddle our thumbs as we send it over a 9600 baud connection, because this is an old computer. This is how we used to send files, and this is how long it took to send essentially a Word document. So, yeah. Man, I really wish I could, like, I had a webcam. Next stream, I'm going to have a webcam set up so you guys can see this. So, I'm running it now. Okay, I see the wire over there. I'm going to head over and I'm going to make a new device, make an AND gate, and see if the wire connects up. So, I to enter device, E to edit, B NAND gate, enter a random value, M to switch to modes, I to insert connection, 0 to 1, 1. So it draws better. But it doesn't draw good. It doesn't draw good. Let me look again. All the way up here. So if it's signal, I want to draw these two. 0, 1, 2, 3, 4, 5. Instead of 5, 6, it's 4, 5. So change this, 4, 5. Now we can get somewhere. Okay. This is still garbage. No. This is correct. Well. No. Yes. This is still garbage, but that's to be expected. Okay, let's do this. Let's do this. If let me look again. Okay. Input device index. When I should have the input I should have set the input. Yes, when I should have the input set. Oh, this thing? That thing right there? That is a PDP-10. It's an emulator, but it is a PDP-10, and let me show you what a PDP-10 is. Now, it's just the front panel, so it's nothing crazy. But it is this. It is a computer, a DEC computer, Digital Equipment Corporation, which is the same company that my coworker that I'm talking to about my code, the code I'm working on right now, he worked at that company that made this machine. And this was the first AI computer. It could basically its claim to fame was you could model a 3D environment on this computer and ask it questions about where's the red ball, pick up the blue box, and instead of doing if then else statements, it used artificial intelligence to determine what you're talking about. And this was back in the, oh gosh, I don't know, 70s, 80s? What was it? 1966. In 1966, we had AI. Now, this is an emulator. This computer was actually something like this. It was something like where, yeah, the actual computer was something like this. Yep, AI, artificial intelligence. We were doing artificial intelligence back in 1966, and that light panel you see that back there, that is this right here where my mouse is. Everything else you see in this image, the tape reader, the teletype, the disk bays, all that is now emulated on an SD card. That's how far we have come with computers. This can all fit on the computer the size of this now. And yeah, that's an emulator that emulates this whole thing, and I run very old software. I run software from 1966 on it. So yeah, anyway, I think that's cool. We can nerd it all day. Anyway, as I said, we are looking at the input. Now, the input device of the connection should point to which input you have selected, the one or two. So if I go to edit connection, update connection, connect device, input equals input. Well, thank you, man. Yeah. And input is your one or two. That's what I'm going to use. So I can actually get rid of indev. Indev means nothing to me. I'm going to get rid of indev, source X, source Y, target X, target Y, and I'm going to get rid of all that extra code that I just do not need. Okay. Do we even need update connection? Oh god. There we go. Okay. Yeah, do we even need update connection anymore? That is a question. Do I need update? We'll figure that out later. Probably not. I probably don't need that. I probably just need to add and delete. Unless I want to edit and change which device it's connected to, but why not just delete it? I can just delete it and add a new one. Yeah, I'll just do that. Okay. Anyway. Okay. So what we're going to do, plus, okay, so we're going to look at devices, right, if devices dev target pointer dot input, no, if connections k dot input equals 1, we're going to do this, else we're going to do that. And then this is, I'm going to say calculate endpoint based on input of target. Okay. So let us take this. Okay. Devices dev dev t pointer dot shape, and we're going to do this. So for 1, we're going to do 0, 1, 2, and 3. 2 and 3 for 1, 4, 5, 6, 7, and 8. 2 and 3, 7 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 and 8. 2. 3, 7, 8. And I'm going to, when I, like, if this works, I'm just going to set indices and do it in all ones instead of multiple. You'll see. Basically, we can make this a little more optimized without too much trouble. See if it builds. You never know. It's always a crapshoot. Cool. Right, I gotta close it. I can't remotely close it because I got rid of the terminal stuff. LOGICSIM.com. So if you don't know, this window right here is a window into that computer, not that cool one, but a computer off screen, the Altair. This is a window into that computer, the one that I'm sending code to and using. We're gonna PC get, we're gonna transfer. Whew. Okay, we're gonna send. I'm getting pretty hype. This is pretty awesome. If I can cut out this code, it'll be pretty awesome. It'll save a lot of memory. Don't worry about the extra memory. Don't worry about that. We'll get rid of it. We'll get rid of it. I don't think I'll need update. I won't need update connection. No, I think I can get rid of that. I think I can just straight up get rid of it. Now let's run it. And I will be back and I will let you know what it looks like. Adding device. Connection mode. Insert 0, 1, 1. We're switching back to device mode. We're going to move the device. It's drawing. We're going to switch back to connection mode. We're going to insert 1. It's going to be 0 to 1. Input 2. It's not working. This is not working. Let's take a look. Zero, 1, 2, 3, 4, 5, 6, 7, 8. What's going on? Oh. 7 and 8. There we go. I just had it backward. So let's do this. Let's do this. Char x1 off, y1 off, x2 off, y2 off. Okay. And then what we're going to do is we're going to move this down here. We're going to move this down here. Cool. So then in here, I'm going to do y2 off, x2 off, y1 off, x1 off. Then we are going to do x1 off equals 4, y1 off equals 5. And then we're going to do (14, 15). 14, 15. Then we're going to do x2 off equals 2, y2 off equals 3, else this is going to be 7, and this is going to be 8. Cool. Look at that. It's so much better, and I'm sure with some clever tricks I could shrink it down a little bit more. Yeah. Let's take a look at update connection. We don't need it. We don't need it. We can literally just select this. We can delete this code. And then we find out where I put it. And it's just gone. It's just gone. And then we don't need this anymore. We don't need this anymore. I'm just looking around. Connect devices. So I'll need to redraw this, but let's just comment this out for now. So let's just get rid of these. Find next. Nope. And let's just get rid of these. Let's try building it. See if it works. Good night, Harrison. 20.25 kilobytes. That's not as much as I was hoping. StatLogicSim.com. StatLogicSim.o. I mean, it's a bit. It's a fair bit. It's just, I was hoping for more. Okay. LogicSim.com. You should get LogicSim.com. Okay, sending again. Seeing if this this is gonna work. LOGICSIM. So what I'm gonna do is I'm gonna do the same thing, create a device, move it around with the connection. We're gonna just change this to a gate. We're gonna insert another gate. We're gonna change it to a XOR gate. We're gonna create a connection. 0, 1, 1. Okay, cool. We're gonna insert another connection. 0, 1, 2. And we're going to switch back. It works. It works beautifully. It works really well. So let me add back in. Is there a way to make this more like optimized? I could probably turn this into a pointer. I could turn that entire thing into a pointer, and so I don't have to, my god. Dude, why is my webcam? I could probably put that into a pointer so it doesn't have to do the recompute each time. I would just do 2 computes instead. We'll see. That's not necessary right yet. I should really put this into a function. Anyway, what was I thinking? What was I doing? Right, gotta redraw this. Basically, what I need. So I need this code. I need this code into a function that will then draw the cursor. Let me put a pin in that for later. I know what I need to do, I just don't want to do it right now. It's boring. Let me take a look at what Eben said next. So you have, let's look about the, I have char, and he said, I do not know why I have a value for the connection. If you have a value of device, the point was I could see the voltage of the wire. But he's right. If this is truly a logic gate simulator, then I should not need that. Should not need the voltage. There should be no voltage. I also, well, I'll leave that. I will leave that there. Before I go any further, let me go test right quick to see if the logic still works. Let me do it. Cool. Sorry for that. Yes, the logic still does work, so that's good. That's good. I don't think. Yeah, I never used that. So 4 bits total instead of 14. Cool. Now, interconnection update logic is simple, but just isn't exactly. That's, I came out to the conclusion I should have just read that. Edit dev could be a lookup table instead of, if your initialization could be memcopy, and simdev you're assimilating logic or analog if you're right, if then 100 times. More complexity, you could get capacitance, inductance. That would be nuts. I'm not sure if it, well, you see, he says it won't fit in this computer, but good night, man. You're good night. Good to have you on, man. Anyway, sorry. I'm just trying to think here. Yeah, I could have sworn I saw a video of a circuit simulator, like a true analog circuit simulator running on a PDP-1. But of course, those programmers are infinitely better than I'd ever, well, maybe not infinitely, maybe I could hope to be that good someday, but they knew that computer inside and out, in the bytes inside and out, and backward and left and right. They knew how to make it work. So I don't think I could, I don't think it would be impossible for me to do that with this computer. It just is out beyond my scope. But he's right, this is truly just binary. I just want to do binary, I don't want to do voltage. So just do logic, don't do floats. Now the only floats there are for scaling. And he's right, we shouldn't need that. So let me do this. Let me remove the extern. Let me go to value, do char value. We're going to leave the float scale. We're going to delete this line again because that's not, I didn't need that. Char value. So then anytime we see value to value 0 or 1. Scanf is already there, so okay. Okay. Is greater than 0, else 1, 1. Good night, man. 0. Yeah, good night, Harrison. I'm sorry I didn't see that. I'm just so wrapped up. If it's greater than 0, if it's greater than 0, let me just, because 0 is the threshold. Let's just change this to 1. Okay. Now let's change this to 0. Zero, 1. So this might just compile down, but don't quote me. So let's look up scanf. So let us just comment out this. I'm going to use scanf because, yeah. Because maybe you might want to like type in the number of devices you want to jump to, or like something like that, just in the future. So then if I go up here, I should just be able to get rid of the float, huh? $19,625, look at that. Let me, you know what? Scale is awesome, but let me not deal with that right now. Okay, let me just not deal with scale right now. Now let me go here. And let me go here to just delete the math library. Right. Let me just comment this out, because I don't need that right now. $15 kilobytes. That was almost 5 kilobytes of the math library for floats. For IEEE floats. Or whatever passes for IEEE floats. That's how big just that is. That's unreal. That's unacceptable. That's nuts. So it's now under 12 kilobytes. The binary, at least, not the library. So the standard library right now is 16 kilobytes. So let me look at my roguelike. So this is my roguelike. And this is the most unoptimized stuff. And it's like 8 source files, and it's like modern C techniques. There. Stat rogue.o. Right. The entire thing is 16 kilobytes, and the entire thing of my LOGICSIM is now 16 kilobytes. The reason rogue.o is so small is because like it's source files. Literally the same exact file size. I feel a little bit better. I feel a little better now. Because that's this along with all of my terminal code. So let's check that off the list. Another time we can talk about scaling by fixed point and not using floating point anymore, potentially dropping off another library. So we'll do that. We'll do that, Evan. With all these changes, 256 devices, 36 instance totals 3 kilobytes of storage. If you pre-allocate that, you can drop all the mallocs, saving overhead for every single one. You'll need an additional 64 bytes for this.slice used bits for your own memory management. This is way less overhead than malloc, which is probably using these 4 bytes per memory block, 2 kilobytes. Right, just for... So the free memory I don't care about because I don't think I'd ever run into problems there. But I see what he's saying. 256 devices and 256 connections will just be 3 kilobytes. So if I take out the malloc and just do pointers, like pre-allocate everything, you say do that. That's tempting. I'll do that tomorrow. So scaling, I just got rid of scaling right now. The S device can use bits in 1 byte for device type. Value, saving 1 byte. 7 bits for device type, 1 bit for value. I could. But he's saying if you're going space crazy, do that. The problem with that is I think the expense of reading the device type and the expense of it just might be too much. Unless it's not. Unless it's really, well, no, it won't be. I just do like an and and or something like that, like an and or something. I could, but he's like, if we're doing space crazy stuff, we'll do that. So we'll save that for some other day, probably tomorrow or something if I'm doing memory. Yeah, just do logic. So I just work char. So yeah. Which is just a mask. It'll just mask an existing element. So I could do that. Main. So edit dev. Saying edit dev could be a lookup table. My God, where is it? Scanf. Saying this could be a lookup table. Not a stack of if and else ifs. How could this be a lookup table? Am I just... Is he saying... How could it be a lookup table? I'll have to think on this. I'm just not seeing it. I see what he means. It definitely could be. It's just, do I just choose through a list? Because the scanf code is already there. It would just be a simple call. I could just do A, B, C, D, E, F, G and just index off that. I could do that. Let me write that down. Change to A, B, C, D, E, F, G and index of ASCII value to create lookup table. Cool. Let me do that. So I can keep the get char instead. So I can keep that. Jeez, I'm sorry. Ugh. She knows. Then main could use a lookup table for processing characters that move the device around the screen, and I could do the exact same thing. Yeah, I could do the exact same thing in main. Do a lookup table. I think, unless he's saying I don't have to do that and I could just do this. Okay, let me look at Gemini, because Gemini is terrible, like, for writing code. Gemini is good unless you give it a word problem, and then it just falls apart. If you get it simple stuff, like simple concepts, like show me how to make a, linked list or something like that, it'll do it. But if you try to ask, like, I tried to get Gemini to help me out with, Device-Tron code, and it was, with this code, it was a nightmare. Could not get it to work, so I just gave up. And late last night, I just did it myself, which I should have done from the beginning. I mean, you don't learn anything from Gemini. Huh. So next time I'll work on the memory, and then I'll look at the jump tables, the lookup table. Lookup table, not jump table. I'm gonna ask Gemini to just help me out with this. I'm gonna try. With this code, how could I implement the chain of if-else ifs? Let me just, let me put it down here for y'all. Else ifs to a lookup table instead of a jump table. Well, so basically create a struct device type info, okay? And then declare this struct to that. We'll try that. We'll try that tomorrow or something. Yeah. Yeah, we'll try that tomorrow. We'll try it. We'll try it tomorrow. Cool. And I think I can do this. I can do the same thing with a main. Well, that's it so far. Let me test it just to make sure. Again, tomorrow or something, I will have the extension course so you guys can actually see what I'm doing. Okay, let me try simulating the device. It works. It works, folks. Let me... Where is it? Let me do something really quick. Cool. Let me do that next time. No, if devices cell dev value cool. So now I'll just print high and low instead. And then what I actually need to do is go in here. No, never mind. I'm good. Cool. Cool. Let's see. Cool. And let me just upload. I'm gonna go to Git, File, Upload Files. Massive size optimizations, removed scaling, no floats. Removed and.lib dependency, no floats. Changes. Cool. It is now pushed. Well, that's it, folks. I gotta head to bed, and I will see you next time. And we'll make this even better. Good night, y'all.